Welcome. My name is Dana Royer from Wesleyan University in Connecticut. I'm one of the PIs on the CO2 PIP team. And on behalf of the full team, thank you so much for the time and effort that you're willing to put in for this community effort. It's really going to sink or swim based on what you guys do collectively. And we're so happy that you're willing to participate, and we're more than willing to work with you to make sure that this is a success. So you've clicked on this video probably because you want to learn more about how to fill in the templates associated with CO2 estimates based on the stomatal index method. So what you're looking at here on the screen is what we call the blank template, which has the column headers in green. Just above in row 2 is a fuller description and more conventional narrative of what the column header means in a fuller description. So if the column header leaves you a bit lacking or a bit confused, perhaps if you just click one cell above, you might have that information filled in for you. You might understand better what's going on. And then here in row 5 is an example data row. And this is just to help you, see at least one example of the kind, how the data are going to be filled in. Yours might not follow exactly, the example row, but it gives you a sense of kind of what we're looking for. What I encourage you to do is fill in your data starting in row 6, and then when you've gotten to the end and you're ready to submit, delete row 5. It's important to delete that example row before you actually submit. If you have leaf level data, we would like to see that where each row is its own leaf, if it's presented as such. A lot of studies don't present it at that granular level, but if you do have leaf level data, please enter the data at that level. If that's what you do, what we would also like to see is the species average of all of those individual leaves, because that's almost always what's used to estimate CO2. So what you would do after you enter all your leaf level data is to then append, add an extra row at the bottom that has the means or the aggregate values for stomatal density and all of your inputs, and as well as CO2. If you have a study that presented multiple species from a single site, you want to present all the different species, and potentially then there's an aggregate across the species, right? So it's sort of this shell, this kind of this fractal thing as you scale out to a broader level. The bottom line is each template is a single study using a single method. So if that single study presented 40 estimates of CO2, you want to have all 40 there. If it presented multiple species, you want to have all the species represented. If it presented it at the leaf level, that's where you want to start, is at the leaf level. Okay, enough for the background. So columns A through J are common to all the templates. And we did this because it allows for easy machine reading for CO2 and age. You can see here, CO2 and age. And you might note that these columns repeat information that's given in columns further to the right. We know that was done deliberately. But for you, the good news is that the columns in blue, the cells in blue here, are all equation-based, they're referential. So you don't need to do anything. They're going to autofill. You can see that columns will auto-populate. And in fact, I think we've locked these columns. So even if you wanted to type in your own numbers, you can't. But it means less work for you. Columns A through C, you do need to fill in. Column A will be identical for it's a small index estimate, so you're just going to drag that down, as many rows as you need. I'm going to scroll now a bit to the right here. We're going to start with some general information about the publication, the physical site that the fossils came from, and the fossils themselves. Sample name that's a fairly general column query where you can put in anything that you think is going to help us identify, like in a museum, where those specimens are found. So if you're entering leaf level data, potentially you have the individual leaf specimen, the specimen IDs that have the individual fossils. That would be fantastic. If you're reporting species aggregates, the name of the site can be very helpful. So here you can see it's a bit cryptic, but CR125 is the name of this species, this ginkgo. It's CR is Castle Rock, and 125 is the species name in number form. So yeah, it could be a specimen number, it could be a site number, anything that you think could be helpful along those lines. We have some taxonomy here, family, genus, species. Where are these fossils physically archived? Now, if we're wanting to modernize these estimates, this is a pretty important column because we need to know where to go. As you can see, these are at the Denver Museum of Nature and Science. Stratigraphic level, this opens up potentially quite a big box here. Anything that helps us get a broader sense of the age. So it could literally be a stratigraphic level, like number of meters above or below a certain benchmark. It could be something that's purely biostratigraphic in nature, like it's Maastrichtian in age. That's very useful. Could even be a regional age, like a North American land mammal age, like Tefanian. This is helpful to us because we want to continue to be able to update the ages moving forward as new geologic timescales are produced. We want to be able to go back, particularly for the biostratigraphically determined ages, and update them. If a single box is not enough, for example, for you to type in all that you need or want to type in, for example, if you have a complete stratigraphic section, feel free to add new tabs down at the bottom. It's okay to add as many tabs as you want with supplementary information. It's sort of only limited by the amount of time and effort that you want to put into it. Just make note in the cell what you're doing so you can guide the reader, as to what those tabs are. That's perfectly fine. All right, the actual numeric ages and the uncertainties you want to give in absolute values, not plus minuses. And you can see the little description here says that exactly, in case you forget. Make sure you type in the ages as they were presented in the original publication. So general, philosophical point here about these archive files. We don't want to play around with them later on. We don't want to be changing them. We want to keep them pristine. That's why we call them the archive files. They should always be true to the original paper. We're going to have an associated file or set of files called the product file, which could have different versions. So it could be version 1, version 2, and so forth, which will update, if needed, anything having to do with what's in this archive file. So it could be the ages, it could be how CO2 is calculated, anything that's modified, that's going to go into the product file, but not here, not in the archive file. We want to keep these pristine and true to the original publications. Well, I was talking about biostratigraphy earlier, so in that would be a good example where you might put an actual geologic timescale, whether it's 2020 or 2012 or 2004, that can be helpful to us. General description of how that age was determined. So if it's Tefanian or Maastrichtian, how did the study go about coming to that conclusion? It could be as simple as biostratigraphy, and you could just write biostratigraphy. You could also go into the more nuances of that biostratigraphy. What set of animals or plants is that biostratigraphy based on? What are some of the nuances? In the sample row that you see here, it's based on geochronology, a uranium lead date, so that's pretty straightforward. It could be magnetostratigraphy, there could be some astrochronology. There's there's definitely a range of possibilities here. Oh, let me go back to here. So anytime that you don't have an answer, either because it's not appropriate or applicable, or just it's not presented in the original paper, don't leave any cells blank. If you're going to leave it blank, please type in NA, capital N, capital A. So you'll see some NAs here as we go forward. It's fine to do that. There's the modern lat long. Hopefully you have that. Probably you won't have the paleo lat long, and that's okay. We're not really expecting you to have that, or the original papers to have that. Probably what we'll be doing is using a single methodology to convert modern lat long to paleo lat long. So we'll be doing that at the back end. All right, getting kind of to brass tacks here, the actual measurements. How many counts per leaf? So oftentimes this is considered a field of view. So how many fields of view do you have per leaf? And then companion to this is, well, how many leaves do you have for that CO2 estimate? So this would be at the aggregate, species level aggregate. How many leaves comprise that CO2 estimate? And how are those stomates measured? We're really hoping that that says microscope and not based on published images or published plates. So this will likely say microscope. And if it does say microscope, any information you have about the size of the field of view, which could be the dimensions, the length and width, or it could be the area in microns or millimeters squared, or it could be the magnification, which is what you see here. All right, how many stomates? How many epidermal cells? If stomatal density is reported, if not, type in NA. And then SI, you certainly hope that there's an SI that you're typing in there, since this is the stomatal index proxy. And then the uncertainties associated with SD, with stomatal density and stomatal index, probably at standard SEM. If not, you should say that it's not standard error of the mean. What modern calibration, what modern or living species was used for the calibration? And either give the equation or the paper that calibration came from. What is that error? Or sorry, how is that error calculated? So here, the Bierlein et al. 2009, this is a Monte Carlo resampling routine, which takes into account uncertainties in both the extant calibration and uncertainties in your measured fossil data set. So some description, you could write a few sentences if you want, but what are the uncertainties? How are they constrained? All right, the money column here, what is CO2? So almost certainly you'll have a number there. What does that number represent? A lot of the older estimates are based on means from regressions. So you would write mean. If you're using a resampling routine like that Bierlein et al. 2009 approach, you're probably reporting medians. So you just want to type in what column AR is. Is it a mean? Is it median? Is it something else? Type that in. What's the range? What's the uncertainty? Make sure you type it in as an absolute value, not as a plus minus. You can see that given here. And then these two columns, what are they? What confidence are we talking about here? Now, our team, we would like to get to the point where we're reporting everything at the 95th confidence level, 95% confidence level. That allows us to standardize across all of the estimates, right? So we're comparing apples to apples. But you want to stay true to the original publication. So just type in whatever it is was given in that paper. If it's the equivalent of plus or minus 1 standard deviation, you'd want to type that in. That would be the equivalent of 68% confidence. But whatever it is, at the back end, that's going to be part of what we do with the product file. Is we're going to try, if we can, get these to 95% confidence. These uncertainties here. What does that probability distribution look like? Is it symmetrical like a bell curve? Is it Gaussian? Or alternatively, is there a skewing? Is it asymmetrical? Is there a tail at the high end, which would be right skewed? If the error propagation was done properly, it's almost certainly likely to be a right skewed distribution. And that's what you can see here. And then anything else, I guess not in this case, but anything else you want to tell us. And if you want to add additional columns that you think would be helpful, you can do that. Just make sure you start here. Don't interleave, don't put in new columns in the middle of the block here, because that's going to potentially affect how we scrape the data in an automated fashion. So just add additional columns to the right if you think that's going to be helpful. So I'll end there, and I'll just say once again, thank you so much for your time and effort, and please feel free, reach out to us if you have any questions as you go about entering your data. Feel free to reach out to me or any of the other stomatal experts on the CO2 PIP team. Thanks.